Hey guys, this is Mrs. Fraser. Today we are looking at how to find terms in an arithmetic sequence. Yesterday you looked at how to write a function rule for an arithmetic sequence. When you are done with this video today, you're to finish the worksheet and then you're to do the circuit around the classroom. The circuit is also on Canvas, so you can complete that for homework tonight. So finding terms of an arithmetic sequence with the common difference. So what is the common difference? The common difference is the rate of change. It can be positive or negative. So I can see the common difference here is 4. And a common difference tells me, is it an arithmetic sequence? If there is no common difference, it's not an arithmetic sequence. So what is the common difference? It's 4. And in this case, it wants to know, what will my fifth term be? So this can be written as T5, A5, or it can also be written F of 5. So if my common difference is 4, I already have term 1, term 2, term 3, term 4. So to get to my fifth term, I'll just add 4 one more time, which will give me 19. So finding terms of an arithmetic sequence with a recursive formula. Write the first 4 terms of the sequence described by the given formula. We're going to also rewrite the formula so we can see it in multiple ways. But in our first formula, I'm given the recursive formula. And remember that the recursive formula means I must have previous term. So I'm literally adding the common difference to the previous term, which is what we just did above. We took our previous term of 11, added 4 to get to 15. We took our previous term of 15 and added 4 to get to 19. So this is just putting it in a formula form. So notice it gives me my first term of 12. And I need to find the first 4 terms after 12. Another way to write this function is f of n equals f of n minus 1 plus 7. So since I know my first term, I just need to find my second term. So to find my second term, if I plug into my function rule, I'm going to do f times 2 minus 1 plus 7. So what this tells me is I'm literally taking my first function, my first term, f of 1, and I'm adding 7 to it. Well, we already knew that. So if my first term is 12, I'm just going to add 7 to that term, and that'll give me 19. If I want to find my third term, I'm going to do 3 minus 1. That's 2. So that means I'm taking my second term and I'm adding 7. So my second term's 19. And I'm going to add 7 to my second term. And then I'm going to take that term and add 7 to that to get 33. So let's look at how we are to find terms of an arithmetic sequence with an explicit formula. I need to write the first 4 terms of the sequence described by the given function. So let's remember the parts of our function of our explicit formula. The first number, this is my first term. And this number, my multiplier, is my common difference. Of course, if you don't remember that, you can always still find your first four terms. You really are just plugging in 1, 2, 3, and 4 into n. Okay, n is my term. So either way, it doesn't matter. So let's just find our first term, 85 minus 2 times 1 minus 1. So I'm finding my first term. Well, 1 minus 1 is 0. 0 times anything is 0. So I'm just left with 85 here. So my first term's 85. So that's just proving to you our formula that 85 is my first term. So if 85 is my first term and my common difference is minus 2, I know my second term will be 83. And my third term will be 81. And my fourth term will be 79. I can still plug all of that into my formula. So for instance, say my second term, I want to know that. I'll plug in 2 to n. Using my order of operations, 2 minus 1 is 1. Two times, or negative 2 times 1 is negative 2. 85 minus 2 is 83. So I'm getting the same answer. So you can see how my formula works together. Okay, so looking at our last section here, determine if each sequence is also a linear function. Circle yes or no. If yes, explain how you know. So remember, for it to be a linear function, I have to have a constant rate of change. So really, another way to ask this question is determine if each sequence is arithmetic, meaning that it has a common difference, that I'm adding or subtracting the same thing each time. If I'm not, then it's not going to be a linear function. So negative 1.5 to 1.5, I can see is adding 2 each 2, but 1.5 to 4.5 is adding 3, and 4.5 to 7.5 is also adding 3. Now this is different than if we were dealing with a table. This is my first, second, third, and fourth term. So I can see I don't have a constant rate of change, or in this case, I don't have a constant common difference. So no, it's not arithmetic. There's no common difference. Okay, let's look at one more together. Let's look at number 10. So number 10, I'm adding 1.5, and then adding 1.5, and then adding 1.5 again. So it has a common difference of 1.5. So yes, it's linear because there's a common difference. Okay, so your job is to finish the sheet and then also work on the circuit.